Technology. I would like to welcome our all the participants on the third day of this FDP, this induction program on cybersecurity and autonomy. Our today's session will be taken by Dr. Gaurav Varsheney sir. Once again, I welcome you, sir. Again, I'm doing a brief profile of sir. Dr. Gaurav Varshney is an assistant professor in the Department of Computer Science and Engineering at Indian Institute of Technology, Jammu. He completed his MTech and PhD from IIT Roorkee and has worked in various security research labs at SUNY Albany, NY, USA, SUTD Singapore, and University of Newcastle, Australia. He also worked as an engineer at Qualcomm, cybersecurity consultant at NIIT Limited, and as an assistant professor at NIIT University, Neemrana. His research interest includes web security issues, network security, anti-phishing, secure authentication, and memory forensics applications, etc. Dr. Gaurav recently got appreciated from the CEO Uday for his contributions in the security of Aadhaar QR codes and is working on various identity and access control projects. So I again welcome you, sir, on this FTP
Thank you.
for
Thank you
this
very much,
session.
Dr. Dolly. Thank you very much, Dr. Latika. And thank you very much, all the participants who are here. So yesterday we had an interaction with respect to security of web. And we have seen some web security issues, some of which I just want to do a recap. So we had discussed how we can have cookies being used for auto logins and what are the different ways in which a malicious entity on the network or who's residing on the web at a remote end can have an access to remote cookies, can have access to the user cookies, and those user cookies can then be used for automated logins at a later point of time. So we have identified that there's so many ways in which the same can happen, and we have also identified that if there are ways in which it is happening, what are the different ways in which we can actually patch them out. And this opens up again a lot of discussions with respect to, can we also automate this process? Can we also automate this process of finding a hack as well as solving that hack? Right? So can we have a self-healing kind of system wherein whenever the browser is able to see that, okay, there are certain problems with respect to the cookies and they can be misused for auto logins, the browsers themselves can self-heal those cookies, maybe put certain kinds of restrictions on those cookies so that they cannot be taken by the hackers from such vulnerable sites. So there are different ways in which the same can be achieved. It's an open area. People can definitely do research in that area, can find out ways in which you can actually find out websites which are vulnerable and can write maybe algorithms, complex frameworks through which you can actually identify how many such websites are there and how those websites can be proactively killed. So even when the developer has written a wrong code, or even when the developer has not focused much on security, can you as intermediate entity, say for example a browser or an extension which is running on browser, alert or maybe repair those cookies? The second thing that we have seen is cross-site scripting. So we have seen that so one of the way in which you can actually get cookies or the information with respect to a user on a website is if you can actually do a cross-site scripting attack. So you sit across the site and you are able to run a script, and that's why we call that attack as a cross-site scripting attack, because you're across the site and you are scripting on that site. So cross-site scripting attacks are quite possible. It's a vulnerability. There are tools already available in the market that can detect those vulnerability in an automatic way. And then there are tools which can actually maybe give suggestions. And there is again an open research area in which you can actually work, and you can look forward to how we can have systems which can auto heal, say for example, websites which are having a cross-site scripting vulnerability, maybe as an end entity, as an intermediate entity. So today we'll actually go forward with the understanding of these two things, and we'll now look forward to one more kind of web attack, which is known as cross-site request forgery. and we'll go forward to understand server-side request forgery as well, which is one of the attack on top of, which follows the same norms as of CSRF, but these are on the server side. And then we will use one of the very popular tool, which is known as BWAP. It's a test bed, you can say, for attack testing on websites. So there are already a lot of vulnerable websites which are hosted by this specific, you can say, platform. And then on this platform, there are so many vulnerable sites, and you can actually experiment, or you can do tryout of those attacks that you have learned over time on this platform, so that you do not affect the public space. You can actually contain your attacks to one test bed. So you can call it as a test bed, and you can launch the learnings that you have done with respect to all these attacks that you have understood. So I'll just close my camera and we'll start understanding that attack, and then we'll take an example on the BWAP. So yesterday we had discussed that there are different types of accesses which are possible, and we have persistent access where the malicious payload which is executing on a website is actually stored by the attacker on the database servers of that website, so that whenever any user visits that website, that malicious payload is loaded onto the website and the victim is infected. The other kind of scripting that we've identified, cross-site scripting that we've identified, was reflected accesses, where actually nothing is stored, no malicious payload is stored on the web server. Instead of that, there is a problem with respect to the server-side code, that it always reflects whatever is provided by the user in input. And then we have identified that there is a DOM-based accesses, in which whatever is reflected by the server is actually executed by the client side script, which is there in the web page. So basically, the DOM of the web page is responsible for executing it, and it's not the direct reflection from the web server which is causing that execution. And we have seen certain cases in which, if we say we are sending a malicious payload, and if it is reflecting back by the website, then how it can affect the privacy of the user or security of the user. And we have seen some of the solutions to that, which is like we can encode the contents which we see are not text. And the second thing is validation. So we can validate if someone is sending a payload, code instead of a text, which is required in an input field. Then what we can do is we can filter that out. The second very interesting attack that is good to understand with respect to the web security area is cross-site request forgery. So there is a typical difference between cross-site scripting and cross-site request forgery. In cross-site scripting, what is happening is the attacker is very interested in running a code into the website, right? So what he's trying to do is he's not part of the website, which means he's not the administrator of the website. So basically, he cannot update the code or run a code as part of that website, but he's interested in executing some code as part of the website. So basically, if you see the browser follows the same origin policy. So if anything has to run on that website, it should come from that website. It should be the same origin. So when you do cross-site scripting, you actually break the same origin policy, because you're not in the same origin and you're able to run a script from across the origin to that origin, right? And then because you're running the script on that origin, whatever you write is trusted as is coming from that website. So for example, if you are doing if you're running a code with google.com, whatever you're writing on google.com will be executed on everyone's browser who is opening google.com, because it is expected that whatever is written in that page is coming from Google. So if you can exploit a cross-site scripting vulnerability, then basically you own that domain. It's a big vulnerability. It has a highest paid price if you detect cross-site scripting vulnerabilities over websites. Now, the difference with respect to the cross-site request forgery is that the cross-site request forgery, the user is not interested in actually executing a payload onto the website, or the aim of the attacker is not to get a payload executed as part of the website. So that's not the aim of the attacker. The aim of the attacker is to get something done by the user uh, implicitly. For example, let's suppose if you are on a website, if you have opened SBI, say online.com, and you are doing banking, right? So what's happening is, whenever you have actually, we have seen yesterday as well. So whenever we are logging in, we are getting some session ID, and that session ID, or say a set of cookies, are maintaining our session with respect to the web server. So whenever we again click on a button, those set of cookies move to the web server, and then the web server is able to identify that this is Gaurav. And that's the only way for the web server to identify that, because HTTP is stateless. Right? So we are not maintaining any state. Every request is a new request. So to make sure that the server understands that this request is a part of the previous connection, there are a set of session IDs and cookies which move which each and every request, to make server understand that you are the one who is doing that request. Now, let us suppose when you're doing banking on SBI, and you're just opening a news web page, and in that news web page, there is a link which is going to SBI. Now, when you click on that link, because you have a session already established with SBI.com on the other tab, browser understands that this request is actually going to SBI. So let us actually take out all the cookies which are there and then send it in that request. So what will happen is, if another tab with another domain is hosting a link of SBI, that click of a link may do some state changing actions. And that is the aim of the attacker in cross-site request forgery. So the CSRF attack specifically target the state changing request. So the target of the attacker is that he shares with you a link on WhatsApp, or he shares with you a link on email. Now, if that link contains a CSRF payload, which means that this link is actually going to a targeted website, and it is requesting a state changing action to that website on behalf of you. You are already logged in on that website. When you click on that link, that will execute. This used to be a big attack. This used to be a big attack in 2015-16 time, when you used to click on some of the links, and automatically what happens is, on Facebook, you give a like to someone's page, but you never know that you have actually did that. So the CSRF attack is different from cross-site scripting, that it forces an end user to execute unwanted actions on a web application in which they are currently authenticated. So basically, you are authenticated on one of the website, and some of the things, some of the payloads which are sent by the attackers and clicked by you, will cause a state changing action on that specific website where you are already authenticated. We'll see an example of that. So basically, the target of the attacker is not to execute any malicious payload on the site, on the targeted site. The only thing that the attacker is interested in is getting something done on behalf of the user on that website. So if the victim is a normal user, a successful CSRF attack can force the user to perform state-changing requests like transferring of funds, changing their email addresses, and so on and so forth. Let us take an example of that. We'll take an example practically as well. So let us suppose that this is the bank, and the name of the bank is bank.com. And let us go back in time, where most of the things used to happen on the HTTP GET request. So what's happening is, there is a very simple way of transferring funds, and it is that whenever the user is on bank.com, if he tries to click on a button, what happens, like if he tries to write on the form account name as Bob and amount as 100, and let's suppose if the person is Alice, then what happens is a link is created, and that link is something like this. It gets executed by the browser. The link goes to the web server. Web server identifies that it is Bob and the amount is 100. So what web server does is, it deducts 100 from Alice's account and send it to Bob's account. Now there is one question that we need to answer, that how the server will be able to identify that it is Alice's account from which the amount has to be deducted. The answer to this question is the cookies, right? So whenever the Alice is logged into bank.com, bank.com will definitely have stored a session cookie. and all requests which goes from Alice web browser to bank.com contains that web cookie. So by knowing that web cookie, the web server understands that it is Alice session. So this link means that you have to deduct 100 from Alice and send it to Bob. So this is the basic implementation of a transfer of a bank account money transfer, right? So we are talking about a time when this is possible. This was there, and when CSRF of this kind is very often. Right? So let us suppose that this is the basic functionality of the bank, and this is all good. There is no problem with respect to that. Now, how someone can do a CSRF to actually cause a loss to allies is that, let us suppose when allies is already logged into this specific site, and the attacker knows that whenever someone do a transfer, then this specific link is created and it is sent to the web server. Now, what Maria will do, which is an attacker, who's an attacker, she tries to exploit this web application vulnerability. Right? So what she will do is she will create a link which matches this link, but changes the account name to Bob, to Maria. Right? So instead of Bob, Maria is here. And then the amount is, say, whatever amount. Now, the trick to get this attack executed is that this attack will only get executed when the link is clicked by a person who is already logged into bank.com. Because let us suppose if I click this link from an arbitrary browser where bank.com is not logged in, this link will go to bank.com. Then the bank.com website web server will see the cookies which are there. It will find no cookies because there is no user account which is logged in. So bank.com will not do any transfer because bank.com don't know from whose account this money has to be deducted because nobody is logged in to bank.com from that browser, and browser will not send any cookie which is active at that moment. So if anyone click on this link where the user is not logged into that website, this link has no meaning and it is not an active payload. This link will only make sense when you can send it to someone and that someone is already logged into bank.com, so that this link, when clicked from the same browser, will take out the cookies of that session and send it to the server. So now what Maria will do is Maria has created this. What Maria can do is Maria can do social engineering attack. So basically, if she's a friend of Alice, she can send this link to Alice on, say, for example, WhatsApp web. So she'll say that, okay, you click on this link and this is a good cat's picture, right? So there are hiding techniques for links. Like you can hide the links in AH reference tag and you can have a different text and a different link. So basically you can have the link is this and then you can have text that, oh, this is a very good cat. And you click on this link. So basically Maria can cause Alice to click on this link when Alice is logged into bank.com, right? So you can actually do a lot of things, like you can send unsolicited email with HTML content. For example, you can send a spoofed email saying that, okay, you click on this link and you'll get a lottery. So you click on that link and you execute that payload. Second thing is you can plant this exploit on script on pages. For example, if you can actually have this link into a tab, that tab is frequently visited by allies, and on that tab you can keep it as a image tag, right? As a link as an image tag. So there are different ways to do that. For example, you can have it an AH reference tag, you can have this payload, and then you can say view my pictures. So basically, whenever Alice will see this specific HTML content, she will just see view my pictures, and the link will be hidden in the back. So when Alice will click on this link, it will actually execute this payload, and this payload will be executed by the browser. Browser will take out the Alice current session cookie and send it to the web server. So web server has no power, or say you can say that it has no means to actually discriminate between these two requests, one which is done by clicking of view my pictures and the other which is a genuine request that allies do from the bank.com website, because both are carrying valid links and both are carrying the valid session cookies at that point of time. So what the bank will do, the bank will take out $10,000 from Ali's account and send it to Maria's account. Other way of hiding this link so that Alice is not able to see that is that you hide it in image sources. and you keep the size of the image as height 0 and width 0, and then you keep this image as in the email. So whenever the email is opened by Alice, then automatically the image is loaded. When the image is loaded, the specific target will be hit by the web browser. So that's why many times it is there that you, whenever you open an email, sometimes email server says that do you want to load the images, right? So most of the times they don't want to load the images from unknown targets, because loading of images automatically hit servers, and those images may contain malicious payload. So if the images are loaded on the email, then they will hit the targeted web servers that the attacker is interested in. So you are not doing anything, you're just opening an email and you're hitting a target, right? So that's how the email trackers are able to identify that you have opened the email or not. So once you open an email, an image is there, it hits the target, and the email tracker will say to the other person that yes, this person has opened the email, right? So the opening of the email gives a lot of information about you. So now this is the way in which the allies can be targeted to click on that link, which can cause a CSRF to be executed. Now, some of the people will say that let us suppose we change that GET request. So here we can see that it's a GET request. So GET request means that you can directly copy and paste it on the browser, because browser, whenever you paste a link on the browser, it goes as a GET request, right? So if the links used by the bank.com for genuine transfers are GET, it is very easy for an attacker to create payloads and get those payloads clicked by the users or append them as images in email. So it becomes easy for the attackers. What if we convert them to HTTP post request, which means that we make a form and then we always take the request from the forms instead of the get request links. So instead of that, what we can do is in the genuine website, we can have a form action field, which is taking to, say, for example, bank.com end point. And then the method is post, and then we are actually taking the information, whatever we are taking, like Maria and $10,000, and we are submitting it to the web server. Now, in a genuine way, this is possible, but then attacker can also create the same form like here shown, and then append this form as a part of a website, right? So it can again create the same form that the genuine website has created, and then it can actually again hide this form in the web page, and in the submit button, whenever the client will click on that button, the form will automatically be submitted. Now the form can be submitted on body.onload event. So it can so you can have a form on the with the specific website, and whenever the website is loaded, that website load will actually cause the form to be submitted. So what we need is that the ally should be logged into bank.com, and then ally should be on a vulnerable site which can have a malicious CSRF payload that get executed at the same time when ally is already logged into bank.com. So if that happens, then also this mechanism or of safeguarding the bank will not work, right? So this is a quite typical way of executing CSRF. So let's take an example so that we can have a better understanding of it. Yeah, so here this is BWAP. It's a buggy web application. So why we are calling it as a buggy web application? Because it is there are web applications, so there are web pages in this application which are buggy in nature, right? Which have already a bug in it, right? That's why we're able to exploit that. So let's suppose if I'm trying to give an example of what we have learned here, CSRF cross-site request forgery, then we can see that there is an example of that. So here we can see that cross-site request forgery change password. This is an example, right? So if we see this example, what it says is that let us suppose if this is a website, I'm logged into that website. So this is, I'm already logged in. So you can see that there's a logout button. So I'm logged into this website. And when I'm logged into this website, consider this as a banking site, and this banking site requests for change of password, right? So when it requests for change of password, that this is your login password, change it. So I say that, okay, my login password, I want to change it to say bug, right? And say this. Now, this is the regular way in which we change our passwords, right? We give the new password and we retype or reconfirm the new password and we change it. So now when we change the password, it says that the password has been changed, right? If we go up here, we can see that it is a CSRF, not a CSRF. It is a get link which is sent to the web server, and is in this link we can see that our passwords, whatever passwords we have sent, are appended, right? So the password new is bug, and then the password confirmation is bug, right? And the action is changed. What it means is that whenever a state changing action happens at the web server to change a password, what web server needs a valid login session cookie, and web server needs this link. If these two things comes at the same time, then the web server will change the password, and it has no means to identify if this link is coming from the click of change, or this link is coming from somewhere else. Let us take an example of that to exploit the same thing, right? So if I go to say this site, and if I say inspect, right, and I want to edit as HTML, and we'll try to use the same link here. View my pictures, and then we'll close it, right? And here we'll try to change the password to something that we like. So for example, you want to change it to B, right? There's a change that I need to do, edit as HTML, B, and this one also has to be B, right? Okay. So now once I did this change, you can see that there is a link which is here, view my pictures. So basically internally it is going to somewhere else, but externally it is showing view my pictures, right? So yeah, right? So it's showing view my pictures, right? So this means that, let us suppose I am logged into this site, and there is an active session cookie with the browser for this site because I'm logged in here, and this is another site, so it's a different site, right? And then when I click on this site, what will happen is, because I'm already logged in, and if I click on this site, the browser will take out the cookie of the active session of bwap and then send it to the web server along with the request of changing the password to B, right? So once I click on that, so the answer comes up as password don't match. Okay, so there's a difference in the password. We need to redo it. So and then we need to keep it as B. B. The password has been changed, right? So we clicked on that link and we see that the password has been changed. So now if I try to use the previous password, right, which was B and bug, bug, right? It says invalid credentials, so it is not activated. So by click of a link, by a mistaken click of a link on another website by me, has changed the password of my account with a specific website, which is having a CSRF vulnerability. So now the password has changed, and it is the password which the attacker has included in the CSRF payload. So it's now B. So if I now log in, then it opens up. So this is one example of the CSRF attack. The other example that we've discussed is that how this can happen if someone is not doing it on the get, right? So if I go to the change secret, let's say change secret, yeah. So here, if you see, if I change the secret, then I don't see anything here, right? So I don't see anything in the get request, right? Because the developer is smart and developer is not sending anything in the get request so that you can actually create a link and put it on another website and get the user click on that link. Because if the user will click on that link, then you can actually achieve your target, which is like getting some state changing request done by the web server on behalf of the user when the user don't know that he want to do this thing or not, right? So a smart web developer can avoid that by not having any get links for state changing requests, right? So why I'm calling it state changing request? Because changing the state of the account. For example, when you were doing password change, it is changing the state of the account. So previous password was that, now the new password is this. The second thing is here also we are changing the secret of that website. So now the previous secret was that, now new secret is this. So it's a state changing action. So the attacker is interested in getting a state changing action done unknowingly by the user, because like previous case you have seen that we have clicked on that link and the password got changed. Similarly, the attacker is interested in changing the secret as well. So what we need to do here, if you see that here, if I do anything, I'm not getting anything what's happening here. So what we do is we go inside. So we inspect that specific uh, form and try to see that what's in there. So if I go inside, I see that change your secret is here, and I see that there's a farm action. Right? Now what I need to do is I need to copy this, right? So basically, this is something which is making the total sense, right? So this is the form which is being submitted. And when it is being submitted, it is going to the web server and the state changing action is being done. So the question is how I can do that, how an attacker can do this again, like the same CSRF attack again, when he can't see something which is traveling on the get link. So another example we can see uh, here. So let us suppose that this is the website of the attacker, and attacker is interested in actually getting that thing done. What attacker can do is attacker can actually add a same form, exactly same form, to his website, and then get the user click on that form, right? So I've told you that how we can actually automate the form, how we can automate the entry of the form. We can automatically enter values. But let us suppose if I have to just show that how form which is added to another website can actually do the same state changing actions on the website where the user is already logged in, then this is one of the examples. So I know that the website is hosted on this specific link. This is the form action, and this is the form that user submits on this page. And the only difference which makes the server understand whether it's a good query or a bad query is the cookie which is traveling. The cookie will travel with this link because the user is already logged in, right? So I know this thing. So I created this form and I just enable this. So the form is here, right? New secret and change it. So I make the secret as root and I change the secret, right? So the secret is changed. Okay, I'm logged out because I was not logged in. So B, yeah. So let's try it again. So right? So we have to capture that event uh, where it's executed. So if we go to, yeah, so in this way we can actually cause a form as well to be a part of another website and cause a state changing action on the website where the user is already logged in. So the main problem with respect to the CSRF vulnerability is uh, that we are not able to limit the cookies which are traveling with the user session on another tab, right? So user is logged in on one tab, and there are different tabs on which he's opening, say Facebook, he's opening Google, and he's opening other websites, and we are not able to limit the sending of credential information, the cookie information, on the click of the same link from any other tab. And that's the problem. That is the difference. That is the reason why the web server is not able to discriminate that which request is coming from the user and which request is coming implicitly from any other tab for any state changing actions. Right? And that's why when the user is logged in and a request is coming from any other tab to do a state changing action, the web server is doing that because it has no way to discriminate between which request is coming from the actual user and which request is coming unknowingly. Cross-site request forgery is pretty much solved by good websites because the good websites nowadays take it very seriously, cross-site request forgery. And what they do is they do two, three things to actually improve that. If we go to the very first thing, then they use anti-CSRF tokens, right? So if they understand that there is a state changing action that this form will do, if there is a state changing action that this URL will do, then what they do is with that specific URL or with that specific form, they actually add a CSRF token. The CSRF token is nothing. It is a token, it's a random value generated by the web server, and it is sent back in the URL to the user on the web browser. And now, whenever the web browser or whenever the user will resubmit that, it has to actually include the server side secret or the CSRF token, which is coming from the web server in the previous request. If the client does not submit that CSRF token during the next request, then the web server will not honor that request. Right? Now, the question comes up is how it is preventing cross-site request forgery. It will prevent cross-site request forgery because this web server token is only available to the client who is actually using it on the tab. For example, if I'm on the tab and if I'm loading a transfer form, NEFT transfer form, then this NEFT transfer form will have a hidden field which has a CSRF token with a specific random value that people cannot guess because it's a big random, right? Now, let us suppose if that form can be copied, like for example, what the attacker can copy, it can copy the structure of that form, right? Because the attacker does not have a live access to the what user is doing on that website. It does not have live access, but it exactly knows how the website is structured because he can open it on his own website, his own computer, and he can see what is the structure of an NEFT form. So you can always copy the structure of an NEFT form and then try to put that NEFT form somewhere so that it gets automatically submitted by the user when the user visits on that website. But what the attacker is missing is that real-time secret, which is the CSRF token, which is a part of that form. So when NEFT form will be submitted, say for example, that NEFT form needs the right CSRF token, which is given by the web server. Because the attacker don't know what is the current value of that CSRF token, the attacker can always create forms. The attacker can always embed such forms so that they get automatically submitted. But those forms will not contain the right secret value of the CSRF token. Thereby, those requests will definitely go to the web server, but the web server will never honor them or never do state changing request because they do not have the right CSRF token, which is expected by the web server. hence preventing all those requests, all those bogus requests which comes from tabs which are opened by the browser in different places, user clicking unknowingly on links. All these things will never cause a state changing action at the web server, even when the user is not is a novice user. He does not know where to click, where to not click, because all those state changing actions requires a CSRF token, which is a real time value sent by the web server on every state changing URL or form. So the web server generates a token, and the token is statically set as a hidden input on the protected form. And the form is submitted by the user. The token is included in the post data. So the web application compares the token generated by the web application with the token sent in through the request. If both these tokens match, then only the web application will do the state changing action. If it does not match, then the web server will not do any change and the request will be rejected. So this is one of the solution to cross-site scripting, technical solution to cross-site scripting, and which is very much working now. And there is no problem with respect to that because the attacker does not have a real-time access to what the user is accessing, so it does not have access to the CSRF token. So you cannot create a form which matches the value of the CSRF token. The second solution that is there is same site cookies. We have already understood yesterday that we can make the same site cookie by changing the value of same site attribute of a cookie to strict. And when we make the value to strict, then what happens is the browser will only take out the cookies and send it to the domain only when the domain of the URL where the user is currently browsing and the domain of the cookie matches. For example, if I am on google.com and if I am actually clicking something on google.com that is going to google.com, then only the web browser will take out the cookie and send it to google.com. But if I'm on an email and if I click on a link which is going to say facebook.com, and if I'm on an email which is google.com, then in that case, if the same site attribute of a cookie is strict, then the browser will not take out the cookies for facebook.com and send it in that request, right? So if I make the cookie a same site, then there are 100% chances, there are 100% win-win situation, because whenever the user will click on a link which is on another domain, which is taking that user to a targeted domain, then the browser will never take out the cookies and send it in that request. If the cookies are not present, the web server will never honor the request because the web server need to know which specific session I have to actually do this state changing request for. So the second important change that you can do is you can make cookies the same site and you can be 100% sure that a cross-site request forgery attack will never happen to the to your system until and unless someone can actually do. Again, the problem is that the same site cookies, even if they are strict, they will be sent when the request is happening from the same domain. So if someone is able to hack your domain and do certain changes so that CSRF payloads can be executed, then definitely it will not help. But in a regular condition, when the domain is owned by you, it is very much genuine. It's not compromised. In that case, same-site cookies will help in avoiding any such things. The third very good answer to this is that if you can actually honor the referrer header. However, that referrer header is something which is sent by the client. So client says that if you are opening google.com or say gmail.com and if there's a link on gmail.com that is taking you to facebook.com, then the browser appends a referrer header saying that we are going to facebook.com, but who is referring us? It's gmail.com, which who has referred us to facebook.com. So when facebook.com reads that referrer header, it can understand that the request is coming from a link click from Gmail and it is not directly coming from Facebook. So it may not honor such request if they are state changing. The other way of doing that, solving that problem in a very simple way, is that ask your user to log out from the sessions whenever they are done. This is the most beautiful way of solving CSRF, and because the state changing requests are happening because user is logged in. The user is logged in on the bank.com site, and then what's happening is anything that he clicks on goes to bank.com. Bank.com actually does that because bank.com understands that you're logged in and you are doing this request. What if I log out from my account? So once I'm done with the work that I'm doing, I log out from my account. There are no active session cookies. And if I click on any link, it won't change anything on bank.com because I'm not authenticated now. So the best way of, or say a user specific way of solving CSRF is to ask your user to log out from their accounts as soon as they are done. One of the very good thing that you see in bank websites is that Bang website logs you out immediately after, say, few minutes if you are inactive. And that's a very beautiful way to prevent any cross-site request forgery, because any cross-site request forgery won't work if you're logged out from your website, because then there's no active session, and anything which goes to the bank from your computer unknowingly, the bank will not honor that, because the bank understands that there is no authenticated session from your computer to the bank.com servers, so it will actually just remove it. So these are different solutions to cross-site request forgery that are taken by the security experts to avoid any kind of hacking that is possible. Another type of request forgery which happens is server-side request forgery, or SSRF. So SSRF is a more specific vulnerability. What happens is here, what's happening is you are trying to actually cause the server to do request for you, right? So that was cross-site request forgery. So basically, you are across the site and you are doing a request forgery to a targeted website. Now, what you are doing is you are across the site, but you are actually trying to make server do that request forgery for you, right? In this attack, the attacker induces a server-side application to make HTTP requests to arbitrary domain of the attacker's choosing. So now the attacker is trying to leverage whatever are the capabilities of the web server to actually do state-changing requests from the web server to any other machine. Right? So in a typical SSRF attack, the attacker might cause to make a connection to an internal services and organizational infrastructure, and to even cause the third party connect to the third party servers with which the server has an association. For example, when you're trying to get the server do a query for you, because the server has higher level of privileges with respect to the internal systems that you don't have, you can get more amount of information if you can identify a server-side request forgery attack on any specific website. Right? So what you do is you try to send a payload to the server, and you believe that server will try to do this query for you, because server is having a higher level of privilege than you sitting outside the organization. Whatever server will fetch will always be a privileged information, and that's what is the target of the attacker. For example, here you can see that this is a specific typical post request which the attacker has identified. So whenever the attacker goes to looking for whatever is in the stock, so for example, if he's on a website that sells vegetables, so what the attacker has done is when he searched for vegetables, he has tried to sniff that traffic through Burp Suite, and he has identified that this kind of traffic moves on the internet, right? He identified that in that traffic, he see that there is a stock API, and then in stock API there is a URL, and this URL is actually fetched by the web server on this specific URL and port 8080. Right? So this specific thing goes to the web server. The web server actually executes this, and then the web server comes back with whatever is the result of this execution. So he identifies that instead of writing this specific URL, if he changes this URL to something else, will the server request that specific thing for him or not? Right? So now what he does as an attacker is that he changes this URL to HTTP localhost admin. So basically what it's doing is, because this is executed by the web server, if I say HTTP localhost admin, then it means that the web server's administrative interface. So if this executes fine, and if the web server is novice, then it will give the admin URL of the web server to a party who's sitting outside the organization. So we are trying to do a forgery by making a change in the existing working of the API to actually cause a third party, or say any URL locally or externally to the web server to be queried. Now, instead of that, let's suppose if the attacker knows exactly the IP addresses of the internal services which are running in the web server, not web server, in the organization where the web server is located, then what the attacker can do is the attacker can actually replace that specific localhost admin with the specific URL of the internal services, and then he can make the web server query to those internal machines and get access to those machines. Right. Instead of that, maybe the web server has privileged access to, say, Amazon APIs, or privileged access to specific services. So he can actually replace this URL with those URLs where the web server is already authenticated, and then he can get access to that data as well. So SSRF is again a very typical vulnerability, which if available in web servers, then the web servers can be used as a intermediate tool to get privileged access to information related to an organization. Uh, how you can prevent that? So basically, you can whitelist and blacklist the URLs from web server to internal systems. For example, if you're getting a request like this, and you can blacklist that if there are IP addresses in the request of the stock API, then I will actually just not do any kind of query. Or if the URLs are like that of a specific pattern, then I will not do as a query as a web server. Or I'll not take anything which is other than certain APIs to be queried by me from external post request. You can also do proper response handling so that responses from internal systems should not be provided to an untrusted client. So let's suppose if there is a response coming back. So let's suppose you queried that specific information from an internal web service, and then you are sending it back to the external client, then you can actually see that this seems to be a private content. So I should not send it back. So you can actually have solutions through which you can see if there are responses which are very private and sensitive in nature, then you can actually not send it to the untrusted clients. Then you can have authentication on internal servers. So you were able to use this. People were interested in executing this because they were believing that web server will not have any kind of authentication to access this specific URL. What if the web server also have to authenticate whenever they have to use a specific access to an internal system? Then in that case, this will not execute. So what you can do is you can put authentication on internal servers as well. So even if the server is internal to the organization, then also it has to authenticate itself before accessing any information from database servers or servers which are present there. But attacker can be smart, so attacker can use alternate IP representation. It can convert IP to hexadecimal or octal format. There can be fake domain resolutions. For example, you can get your own domain and get it resolved to 127.0.0.1 to make it local host and get access to the information which is present there. You can have whitelisting. So for example, if there is a whitelisting and it is saying that I am actually allowing abc.com, then this specific URL will be allowed, but actually this URL when executed on the browser, it's actually not going to abc.com, it's going to bcdev.com, because whatever is after that rate will get executed instead of whatever is before the at the rate. So these are the different ways in which someone can circumvent the common SSRF defenses which are present in the web servers. Now, with this, let us take an example of brute force automation using a verb suite, where we will try to see that how nowadays uh, hackers are automating. Not nowadays, even if you go back in time, you can see that there are different ways in which hackers are automating or breaking, brute forcing the login ID and passwords of systems. So I've taken an example of a target. So let's suppose if the target is one of the test target which I've created, and once I've actually captured what is the login, how the users log in on that specific website. So I've actually captured their post request, identified that people provide a specific username and password, and that moves to the web server. Web server authenticates it and then given access to that specific user. And I exactly don't know what is the username and password. So what I do is like I put the specific username and password, and I know that this is the structure of the request which goes to the web server, but I exactly don't know what is the username and password with which a specific user logs in. Right. So how I can automate this process of identifying what is the specific username and password of a user on the internet. So for example, I know that X user has an account on the website, but I don't know what is the username and password of that X. Right. And I need to automate this process because I want to know that what is the username and password of this user X. So how the hackers do it is that the hackers actually try to crawl those web pages, and then they try to submit username and passwords of different combinations on those web pages, considering that one of them will get a success. And whatever will get a success is the actual username and password. Now, in the real world, it is very difficult to brute force any username and password. There are two reasons for that. The first reason is that because companies are very good, so basically what they do is they make sure that you create big passwords. Now, when you create big passwords, become difficult. For example, if you see I'm writing a brute forcer, and this brute forcer is, let's suppose it's trying on the payload 1, brute forcing all the possible combinations that specify. So I know exactly what is the username and password of my test account. So I am actually providing that the character set from which the password can be constructed is B and E. But let us suppose if I say that the construction can happen with 5 as well, it can contain R as well, it can contain U as well, it can contain B as well, it can contain N as well. You can see the number of payloads which are increasing. Now you have to try 21,952 combinations to identify that what is the specific username and password of a specific user account. Now, if I increase it, if I make it more complex, if I say that, okay, I'm also using some star as well and percent as well, right? If I say that I'm using JKL can also be a part of the password. There can be a capital CVB also a part of the password. Capital WER can also be a set of the password. So now you can see that the number of requests which we need to actually go with is 100,000. So it's 10,97,440, right? So you have to try 10,97,440 different username and passwords to know which specific username and password is with this specific user account. Now, this is when we are saying that the minimum length of the password is 3 and the maximum length is 4. If I change the minimum length to 6, and if I change the maximum length to, say, 9, then you can see that how much it is increasing, like saying unknown, right? So even if I make it 4 and 5, you can see the request count, how much it has increased. That is the reason why the websites are very interested in making you or forcing you to have a very big password or a very big length password, so that even if someone is trying to brute force your account, he has to try more and more combinations to eventually get a success. So here I know that what it is. So it's basically B. I know that I've just used it 2 characters because I want to make it simple to understand. So let's suppose that this is the first payload, and the second payload is also, I know that is this. And let's suppose now I see the attack. So if I start the attack, I can see that the brute forcer has tried every possible combination of the character set which I have specified in the payload section, in the username field and the password field. So here you can see that it has tried and 200, 200, and everything is 200. So how I identify that which one is the right one? So I can see that basically what is the response code which is different from 200, right? So, so if I see this one, B and B. So here I see 302. Now why it is different? Because if I see this username and password, here I'm getting a PHP session ID, which means that I'm getting active session from the web server. But if I'm clicking on any one of these, I see that the response which is coming up is that you're not authenticated, right? So here it is there that invalid credentials are user not activated, right? So on all these, I'll find that, but if I go to this one, then I don't find this specific response. I get a set cookie of a specific cookie ID set on the response. So this means that when I'm getting a cookie back from the web server, then this is the right username and password. So that's how you can actually automate this process of finding out this thing of with respect to what is the username and password of thing. But when this the scale of this increases, for example, if I increase the size of the username and password, so for example 10 characters, then it is not possible. If it's not feasible to actually do that. The number of combinations will rise like to, say for example, millions. So then it is not possible to do that. But if it is short password, then definitely it is. Now, how you can do certain things more than that. So basically, you can automate this process. For example, let us suppose if the password is short, if someone types just 3-character password. So what you can do is you can suggest them a greater password or bigger password. Or what you can do is you take a smaller password from the user always, and internally you make it large when you actually provide it to the web server, right? So basically what the web server expects a large password, but it's a small password provided by the user. But how you do that, if you do it through a password manager or things like that, it has to be thought of, it has to be discussed. So the this is one of the way in which you can actually see how the automation can help in security. So with this, I will be interested in taking up some questions uh, before moving forward. Are there any questions? Okay, so let us take one more example from the yesterday's class. So we have seen cross-site scripting, right? So um, cross-site scripting is like we are able to have a script. We are across the sites, we are not part of the same site, and we are able to get a script executing as a part of the website. Right? How that can happen? That can happen in two, three ways. The first simple way is that you embed something to the website somehow. And because whenever the page is loaded, that specific script gets loaded automatically. The second thing is you have an input box, you have an input field, and that input field is not neither encoding nor that input field is validating the input. For example, the first name and last name. So if I say this is the first name and last name, then it is just taking it and just printing it, right? Whether it is validating or not will tell whether it will be secure from cross-site scripting or not, right? Because it's already buggy web application, it's already vulnerable to cross-site scripting, right? So let us try that. So if I, instead of that, if I write a JavaScript code here as an input, which it should not take because it is not a first name, it should input validate or it should encode it. But let us suppose if it is not doing input validation, not doing encoding, and if I'm providing this information to the first name and last name, then you can see that there is a pop-up box which is coming up and it is showing Gaurav, right? What it means that it is actually executing JavaScript. It's actually allowing the execution of JavaScript, right? So now how you can exploit that? So let's suppose if I write right? So instead of that, what I do is I want to see what is the cookie of that user, of this specific user on this website, right? So if I do that, I can see the cookie, right? So I can see what is the cookie of this user on this website. So this is enough for me to get a login to this user's account, right? And I can be smart. Instead of alerting this cookie, I can actually do a window.location that we have learned in the previous class and send the specific information to the attacker or to me as an attacker, right? So I can actually direct that information to my website and I can fetch what is the current cookie of this user on this website to actually do an exploitation or to get an access to that user account. Yes, we can have questions. So I see one hand raised. Yeah, there is one question, one hand raised. Whose hand was it? Yeah, so there is one question which I see in on my screen. Can anyone do payment forgery using QR code? And it will, yes, it is very much possible to do QR code forgery. Uh, One of the way which is there is like there are we have seen examples of Paytm frauds wherein People are sending QR codes which are for pay, and they say that okay, this is a QR code. You just scan this QR code and do the respective things, and you'll get money in your account. But what is happening is the money is going from your account to someone else's account. People are novice; they don't understand how QRs work. So basically, they fall for that. Second way in which you can do QR code forgery is that if you can replace QR codes, which are static QR codes nowadays, and then you use that static QR codes to scan them. For example, instead of uh, shopkeeper's QR code, if someone can come up and just replace it with someone else's QR code, the psychological perspective that we have seen is that people don't see where they're paying. So they just scan the code, they say 20 rupees, and then they just show it to the person. The other person is also not very interested in seeing that whether it's going to me or it's going to someone else. So you just do it and then say that, okay, I've paid it. At the end of the day, you'll find out that I didn't get any money. So yes, there is a possibility that you can hide images in QR code. QR code can store an image very well. And there is a possibility that you can uh, send some payload in QR code, get people scan it, click on it, and get infected. That possibility is also there. QR code is not very much. It's very new area, so there might be a lot of vulnerabilities. BWeb application can be downloaded from a website. The name of the website is ITSec Games. It's a website that supports a web application vulnerability testing. So you can go to that website and you can download BWeb. There is another very good tool, very good, you can say, test bed, and that is DVWA, Damn Vulnerable Buggy Application. So you can also use DVWA for the same thing that we have done. Both solves the same purpose. Both are for the same purpose. Thank you very much. You can always read some of the literature in my Google Scholar if you're interested in this area. There is some work in malicious browser extensions and new ways of phishing uh, that might interest you. Thank you very much, Dr. Latika.
Thank you, sir. Uh, Thank you for the today's session. Uh, so I think this session is very informative and for our participants, and participants will be benefited by this session. Thank you so much.
Thank you for the invitation. Thank you so much.
Thank you, Dr. Gaurav.
Thank you very much, Dr. Latika. Thanks for the invitation. Thank you.